Hi, Mridul,
Hi
how are you?
Manas. Hi, I'm good. How are you?
Thank you for showing up on time. Before we begin, I just wanted to give you a quick overview of how the interview process is going to go. It's going to be more of a 45-minute discussion. There's not going to be like hardcore lines of code that you need to write. It's going to be more a generalized discussion and how your problem solving abilities are, etc., right? And I'll give you a countdown before I start. And in case you have any questions beforehand, feel free to ask them right now.
Sure, I guess we can go ahead.
No questions. Okay. Cool. So let me just start the timer. It's 1:15. We'll wrap up at 2. Okay.
Okay.
Cool. So just give me a quick overview of what kind of games you made, what you like about game development, and then we can start off from there.
Yeah, so I have made a good amount of personal projects and worked on some other stuff also. But what I choose while working on is that something that has offered that has something to offer new to me as a game developer. So if I'm getting a chance to work on some new features, new kind of stuff, something that I'll have to think about how to implement, something that I have not done before. So that kind of challenge excites me.
Hmm.
And the thing I like about game development and the whole process is that the feedback loop that it offers to me. Suppose that I write a few lines of code to jiggle with the gravity, or if I write a few line of codes to add a force on some body, and when I hit that play button, I get an instant feedback of what I have written, of what I have done, what my code is doing, and that I find really engaging as a whole process. So that is something that I really like about the game development process.
Okay, so you mentioned like gravity and forces, etc. Do you like to be more on the gameplay side of things, or are you more of a back-end kind of a person?
I like to be on the gameplay side more
Hmm.
because, like I said, the feedback loop is something that keeps me hooked.
Okay. So since you're more into gameplay, let's start off with more of a gameplay kind of a problem. Have you ever played Angry Birds?
Yes, I have.
Okay. Let's take Angry Birds Space as an example, right?
Okay.
And I want you to simply recreate the main in gameplay loop of catapulting
Hmm.
what do you call it? Uh,
But
a bird from a catapult onto a certain thing. So how would you go about creating such a system, including how the trajectory is plotted for that particular bird? So
okay.
start off based on that and see how you approach the problem.
Okay. So first of all, you mentioned that Angry Birds, the space version, right?
Yes.
So it has the space version has these planets in its levels.
Don't need to worry about it.
Okay.
I'll get to the space problem later on, but right now think of it on a vanilla Angry Birds
Okay.
canvas.
So basically, when you consider the physics of the game, it's
One one thing you can simply screen share and start jotting down notes if you
yeah,
want, so that I can also understand how you would approach. Plus, it always helps to put pen and paper together. And
yeah. So basically, if you consider uh, the basic physics of the game, so
hmm,
there is an object that we have, and we have to uh, make a mechanism which can pull the object and throw it with a certain force, and according to how hard we pull that object,
hmm,
uh, more force should be applied on that game object.
hmm,
So it will uh, behave it will go ahead in a somewhat projectile motion,
hmm.
and what we need to do is that we need to create some kind of a spring mechanism for this catapult.
Hmm.
So to do that, we can use spring joints in uh, Unity, and what it does is we can attach the this bird or any other game object with the catapult game object uh, with a spring like mechanism. So we can set the dampen value and uh, other kind of properties, and it will act kind of like a spring.
Okay.
And with that we can clamp the value for how long we can stretch that. And upon releasing our mouse button or some other input, we could add a force to that body according to the amount, according to the distance that uh, bird is with the catapult, I guess. And that would mm, just push that body in that given direction that we are pulling.
Hmm.
And yeah, so that's the basic physics of it. Now the interesting part is that we get a trajectory plotted before the game object is being released.
Hmm.
So to do that, basically we have to predict our path that the object will take. So it would be better, I guess, to implement our own custom gravity in this case, uh, to write the logic for our own gravity, and use that with some other body to predict what the trajectory is going to be. Because if we have implemented our own code, we can kind of predict easily that where it is going, and draw a line or a set of game objects like dashes or just simple points along that trajectory after some time interval.
Got it. But like, say I don't want you to use spring joints, right?
Okay.
Because that is like a pre-made solution out of the box that Unity
Yeah.
provides you. I want you to simply come up with like a simple solution. You don't need to worry about making the catapult look very good, etc. Just think of how the shooting mechanics itself would work. Say you're creating a simple prototype right now,
Yeah.
seeing how a quick click and drag can be simulated. I don't want you to again focus on the visual aspect of it. I just want you to focus on the gameplay aspect of it. So how
Okay.
would you go about creating such a system from scratch instead of using like a tool that is there out of the box in Unity?
Got it. So the simple prototype that I would make would have this, I guess. So first we select that bird or the object that we want to throw,
Hmm,
and once we select that, then we drag it. So that's the input we are getting. So while we are dragging it,
hmm,
we will calculate the current position of the bird from the position of the catapult, so that we can get how far away it is from the catapult. According to that distance, uh, we will add a proportional force to it. The larger the distance from the catapult, the more force should be applied on that body upon releasing from that position. uh, and we will also get the direction while calculating the distance between the position of catapult and the position of the bird that we are currently dragging.
okay, how would you get that direction? Can you
So
show me?
in Unity, we'll just subtract the vector 3 representation of position of catapult
Hmm,
from the current position of the bird that we are dragging on the screen.
hello.
And we'll just normalize it to get the direction, and we'll multiply it with the magnitude of the force in that direction
Hmm.
in which we want to uh, mm, mm, make that body go, basically.
Got it. So this is vector math. Basically, what you're saying, you'll subtract the end position with the starting position and get the direction based on that, right? And that will give you the magnitude. what will give you just the direction? Say I want to give the player a added ability that you can shoot your bird with even more force, for example, for
Okay.
and over there your this logic might not work. All you would need is the direction. So how would you get just the direction in this case?
Okay. So direction in vector representation is basically a normalized vector, right? So if suppose we are taking a distance between 2 points,
Hmm.
so if we normalize that distance,
Hmm.
so then it is basically the direction from one point towards the other point.
Hmm.
So when we are subtracting the current position of the bird with respect to the position of catapult,
Hmm.
then we can calculate the direction from the bird with respect to the catapult.
Got it. So what is a normalized vector?
So a normalized vector is basically a vector whose magnitude is 1 in each direction.
Okay,
When
and why do I need a normalized vector in this scenario?
well, so that according to the so if we have a normalized vector uh, in the direction that we want our object to go, so we can directly just multiply with the force value that we want to inflict it upon.
Got it. So in this scenario, say I want to add 100 units of force,
Yeah,
how would you go about? So maybe I have a power up that can add 100 units of force to the bird, right?
yeah,
What your normal line of code look like? Just tell me verbally, you don't need to write it.
yeah. So well, I will be having a normal force multiplier according to the distance uh, from the catapult and the bird,
Hmm.
but I will also add another force multiplier in that line for power ups and other external stuff.
Okay, but where would the normalization come into this picture then?
Hmm.
Did you understand the question or do you want me to repeat?
I would like you to elaborate on that.
Okay, so you just told me that first you would subtract the positions, right?
Yeah.
Then add certain force and then the multiplier for a power up or something.
Yes.
Over here, you did not mention normalization at all. So I just want to understand where would normalization come into the picture with the answer that you suggested.
Normalization would come into picture here with respect to direction, like when we are calculating the direction. So
Yes.
when we are when we are subtracting the position of catapult and the current position of the bird,
Hmm.
it's not normalized. That's a distance we are getting, so we want to normalize that value so that we can have a normalized vector which indicates the direction, and then we can add magnitude according to the power ups and the distance to
Got it.
that normalization.
So now what would be the sequence of the calculations over here?
uh, first we will first we will calculate the distance between the two objects,
Hmm.
then we will normalize the distance,
Hmm.
then we will multiply it with the force that we have decided to apply according to the distance,
Hmm.
and then we will check if there is any power up or any external factor that uh, manipulates this amount of force, and then we will manipulate it accordingly.
Cool. Okay. Sounds good. So now let's continue building on this system that you made, right? So right now, say your catapult system is working as you want it to work. You
Hmm.
said you would use your own gravity. Can you tell me why do I need my own gravity in this scenario?
Well, from my experience, Unity's gravity can be uh, not reliable at times. because it's not it doesn't depict real gravity very accurately. And suppose if our game is 2D or 3D, it also changes. uh, the physics also changes because Unity implements uh, physics using different physics engines according to if it is 2D or 3D environment.
Hmm.
So it is always better from my experience to implement gravity. And if we are making such a physics heavy game, then we should have more control on the physics and gravity and all. And especially like you mentioned, Angry Birds space version, so it has planets and all. So implementing gravity in that would be tricky. It would be better to customize it according to our needs in that case.
Okay. So how would you go about setting up such a system?
So, well, gravity, if you look at it, is basically an acceleration. So, if uh, if a body is experiencing the force of gravity, it
Hmm.
is basically moving with a velocity in a certain direction, and that velocity is being changed every frame because um, it's being accelerated or deaccelerated uh, due to the gravity.
Hmm.
So let us say if I have to replicate that planet mechanism. So there is a sphere or a circle which we can call a planet, and this planet. I'm sorry for my drawing.
Yeah.
And this planet has some gravity. So basically, what we want to do is that if there is some object here, then at this direction, at the center of this planet, this object is uh, this planet is due to this planet, this object is adding some velocity in this direction
Hmm.
at each frame.
Hmm.
So at each frame, its velocity will increase and it will kind of go down with an increasing speed. So what we can do here is we have to change this body's position.
Hmm.
And suppose we know that currently it has x velocity in this direction, right? So we have to calculate how much distance it should cover in a particular frame. uh, so to do that, we can multiply this value by time dot delta of time.
Hmm.
And in each frame we will increase the velocity of this game object according to the uh, gravity that this planet is inflicting upon it. And our velocity will, suppose I'll write it down here. So let us say this uh, object or this bird has a rigid body, and its velocity is being increased each frame by the force of gravity uh, into time dot delta time.
Hmm.
And what we can do is that we can even have a constant gravity for the whole scene, and some uh, mm, gravity scale or multiplier that we have for each different object. So one planet could inflict higher force of gravity, and other small one could have less gravity force.
Hmm.
So we can change the velocity for in each frame little by little, and accordingly we can
But just to understand over here, you're
yeah.
still using Unity's rigid body to
Oh
control
yeah,
velocity, acceleration, etc., right?
yeah. Yeah,
So
you're right.
if you want to create your own system, why are you still relying on Unity's physics?
Yeah, this the velocity part brought me back to it. So well, in that case we'll have to define our own velocity also. In that case we'll just have to use the transform component altogether and uh, just maintain a variable called velocity in our scripts, and just use that variable
Hmm.
while inflicting gravity, because we are going to change that velocity variable in each frame, which is what acceleration means, and according to it we will also be changing the position of our object uh, in each frame.
Got it. So say there, like, let's build again on top of this, right? So you
Yeah.
have your own gravity. Say you're in space, right? There's
Yeah.
one planet uh, below, and
Hmm.
there's one planet slightly on the right side above, right?
Yeah.
And you want both planets to influence the physics of the world.
Yes.
How would you decide what planet influences how much force is exerted on the bird based on how close they are to a certain planet or something?
Hmm. So if you see the Angry Birds space game, so each planet kind of has a highlighted area
Hmm.
that it can influence.
Hmm.
So it's a concentric circle around that whole planet. So what we can use is we can just use a circular collider or a sphere collider uh, in Unity, and we can use it as a trigger. So if uh, any object enters that zone,
Hmm.
then it will just get the reference of that planet, and according to its gravity, that object will now be influenced by that gravity. So if there is an intersection of this influence area between two or more planets, then the planet which is higher gravity, or which is inflicting more gravity at a certain direction, will just take over the whole physics, and the result of that all those forces being applied on the object at a particular time, the higher force will, or the summation of all that force in every direction, that's where just the object will go.
Okay, but what is there is some overlap, for example, in the gravitational force field for this versus this. Plus, the problem over here is again that what if the don't you think the player would again notice some sort of jitter or sudden force acting on it as soon as it enters a certain orbit or something? What if my basically what if my bird is very far but it's still experiencing some sort of force that is gravitational force? Say it's not experiencing anything, and as soon as it enters the orbit it starts getting pulled, right? That is
Hmm.
also not how you want to depict accurate physics in your game.
Yeah, so I guess then in that case we'll have to just take the distance into account every time, distance between that planet and that body. So we could use, I guess, that basic formula that we uh, were taught, because it also takes care of uh, the distance.
Okay, can you like even if you don't know it, like feel free to Google it and describe it, the formula that you're talking about.
Yeah, sure. So this is just basically the Newton's law of gravity, the formula.
Hmm.
So this just indicates that the force of gravity between two objects is dependent on the mass of each object, and it is inversely proportional to the square of the distance between those two objects.
Yes.
Uh, and so in this case we will not have a trigger on that game object, because as you said, the user might experience like a jitter or something as soon as that body enters that trigger.
Hmm.
So instead of that, the whole time we'll just calculate the distance, and according to the distance we will set the value of gravity for each planet, so that uh, the whole time it is experiencing or calculating how much gravity it is experiencing for each planet, so that it is a smooth transition.
Okay.
And
So what is the formula over here?
yeah, so the formula is the mass of one body into the mass of the other body, which will be the bird and the planet, and upon the square of the distance into g, which here will be the global gravity value that we are assigning for every game object.
Hmm. Cool. So is this value then you need to apply for all the objects that are there that are getting influenced by some sort of forces in your scene, or do you think it has to be some other way around?
Well, we don't want every object in our scene to be influenced by this. We just want the bird to be influenced by these forces. So I guess we'll just have the references of all the planets uh, for the bird game object,
Hmm.
and the bird will just that bird will be calculating the force of gravity using these formulas, and only that bird will be affected.
Okay, but what about the other planets? You do want the bird to collide with them though. So if
Hmm.
how would you determine what what will stay there basically, or what will move in your own system, not the talking about Unity system right now?
Okay, so basically, the what we want is the planets to be static and do not want interplanetary gravity being inflicted in our scene. So we want them to be static. So if we would have had a rigid body, you just simply turn the static, just toggle it to that. But currently, we will have to just put a condition while uh, calculating these gravitational forces, that if the object that we are interacting with is a bird or a planet, then only we should use this custom gravity. Otherwise, we don't want that.
Hmm. Cool. Maybe so you would create more of a flag kind of a system in your own physics that would determine what is influenced by certain things and what is not. Is that what you're saying?
Yeah, considering the design of the game, I would say that we can do that.
Okay, but if I were to say add another layer over here and I want objects that can move, basically what we call as kinematic objects inside your
Got it.
scene, right?
So basically, like there could be two planets just revolving around each other in the level design. We
Or
need to
maybe some
calculate.
debris or satellites that are revolving around the planet, etc. How would you simulate those?
Well, we could do that using flags also, but I'm trying to think of some other way.
Hmm.
Well, what we can do is that we can also just provide a like a very high mass to the planets with respect to the other objects like satellites and birds that we want them to move. So in that case, the uh, gravitational pull for the planet itself will be very less.
Okay, but don't you think this is a very, say I have like small debris, 100 objects around
Okay.
the planet. Do you think that would still be the right thing, or what would be the drawback of the system that you mentioned in this scenario?
Hmm.
Like that's the question. What would be the issue if I had like 100 different objects all revolving around the planet?
Well, it would be first of all too much calculation, and then other thing is that there would be also if there are hundreds of game objects, they would be interacting with each other while revolving around the planet also. They would be colliding and basically disrupting each other's motions in in their orbit. So that's one thing.
Hmm,
And uh, as the number of objects keep on increasing, it will be kind of heavy.
hmm.
uh, so
Okay, can you optimize this?
Hmm. See, but every object is its own individual, unique uh, thing with unique properties, unique mass, and the force and the trajectory that it's going to have
Hmm.
should also be unique.
Hmm.
So it must have all those calculations for itself to uh, determine the trajectory, determine the physics for it. Uh,
Okay, but I would like counter say you the designer comes to you, right? Saying I want this particular feature and it's like screwing up your game to say 10-20 FPS.
hmm,
But the designer is adamant that he wants this feature by hook or crook.
hmm,
Then what would you do? Like there is an obvious solution to this. Like if I were to like if what is the difference between a kinematic rigid body versus like a dynamic rigid body?
yeah, so kinematic rigid body basically it uh, follows a certain motion, but it is not inflicted by additional forces or other physics that you apply on the runtime. So suppose there is a moving platform, it's a kinematic rigid body. If I add a force on it using rigid body dot add force, it won't work. So in dynamic rigid body, on the other hand, it gets affected by all the physics in the Unity's physics engine. But kinematic is somewhat like a static body, but you at a certain extent you can control its movement, position, rotation, and like that.
Got it. So you just said that kinematic bodies are not affected by other forces, right?
Yeah.
Then why do you need to calculate all these forces if it's not going to be affected by it any which way?
Okay. So basically, what we are saying is that they should have a static orbit or static trajectory, like a predetermined movement, like a kinematic body, like
Yes.
a moving platform. Okay. Okay. Yeah, if satellite is there, then it should probably already be in orbit, so that movement would be uh, uh, predictable, and it won't change unless it gets collided with any external object like a bird or something. So we could just yeah, I thought that like other objects are coming in and out just like the bird, and they're getting affected by the gravity also.
No issues. Cool. Let's park this one for now. Let's move on to the initial problem that we discussed as well. The only piece remaining right now is your trajectory that you need
Yeah,
to.
trajectory. That's actually something that I'll also have to think about, because I so the thing is that we have to predetermine the path that it will take.
Hmm.
So we are suppose we are using a custom gravity code. We what we can do is that suppose we there is a whiteboard and I will to yeah. So suppose we want a dotted line like this, or with a like a dashed line of
Hmm.
a of to determine the projectile motion. We need to uh, we need to be sending something, some object or something like a point or a dash itself with the same force in that direction, and just plotting it, just seeing where that dash will be at a certain time interval, and then rendering it to form a line or a path or somewhat.
Hmm. Okay. So, but how would you make sure that the line has like the accurate points inside uh, as well?
Hmm. So Yeah, so basically it's something like what I'm thinking is that suppose I have a game object and I apply a force in this direction, so
Hmm.
it goes in this direction, right? So basically at a certain time interval I'm just recording its position, and just at that time interval I'm just putting a sprite like a dot or a dash or something. So my only concern here is that this is very like a primitive thought, and like this is what I can think of first hand. But the thing is that while I'm dragging it here and going just dragging it here very fast, so at each and every frame I have to just calculate all of this, draw and render all those dashes and points. So mm, it's not good.
Okay, keep going.
So
Let me like give you some more data, right? Say I only want 10 points to show up.
okay.
How do you think you can approach this then?
Hmm. Well, we will one way is to just, since we are using a very customized uh, physics or customized gravity and all of that. So what we can do is I think we can predetermine exactly how much time it will take
Hmm.
to collide if we release it from a certain position,
Hmm.
and mm, within that time frame we will just break it into 10 pieces, and for each, suppose it we suppose we calculated that it takes 5 seconds for this whole projectile motion to complete and collide here.
Hmm.
So in that time frame we will just, at every zero point 0.5 seconds we will have to determine where the object will be at that zero point 0.5 seconds. So we'll have to use kinematic equations uh, for the projectile motion and determine if this is the time, if it is at 2 seconds, then what is the position in on x-axis and y-axis, and accordingly we'll just plot a dash or a dot or whatever for that trajectory. But it will, I guess, mm, it will take down the performance by a lot, but it will still be an issue if we are just, if the user is just going mad while dragging it around here and there.
Okay. But over here again, you're getting into simulation, right? You're basically simulating the entire projectile.
Yeah,
But you mentioned something like, uh, don't you think you can simply do this by math instead of simulating the entire physics? So if I basically tell you, right, that, okay, I have this car that runs at 100 kilometers per hour, right?
mm,
And I want you to determine it's not going to stop, or maybe there is some friction that's there that's slowing it down behind the scenes, etc. And I want you to calculate where it would be after 10 minutes, 20 minutes, 30 minutes, etc.
yes, yes, yes.
Do you think you need to simulate how the car runs in order to understand where these different positions would be, or do you think you can actually simulate, or sorry, calculate where it would be by
Yeah,
simple math?
definitely we can calculate it. So suppose we already know, according to the current position where we have dragged the bird to,
Hmm,
what the force is going to be. So what the initial velocity is going to be, we can determine that. We
hmm,
know that at which time, 2 second, 2.5 second, 3 second, where we need to calculate where the dash will be
hmm.
at that particular time. So we have that time also. So we have all these variables, we can put it in the mathematical equations like you said, and we can just use that math to determine the position of each dash or each part of that line we have to render to plot a path before releasing it.
Okay, show me how you would go about. So what formula would you use? How would you go about setting it?
Mhm. So I don't remember fully the kinematics
And feed
equation, but
what formula would you mentioned one important, uh, what is this kind of motion called?
parabola.
No, no,
Oh,
but
projectile motion.
okay, but do you think you need high level kinematics, or do you like? Do a simple Google search and find me the answer is what I'm trying to ask. I don't expect you to like know all these formulas, but it's helpful if you normally do. But since we are short on time, like feel free to Google.
Okay. So for each axis, we will be calculating the position on X and Y.
Hmm.
So yeah, there are three equations. Uh, so we know the initial velocity,
Hmm.
we know the acceleration, which is gravity,
Hmm.
we know the time period at which we want to calculate the velocity at.
Hmm.
So okay, we will. Yeah, so we will need to use this third equation where the final velocity ka square is equal to the square of initial velocity plus 2 into the acceleration, which is gravity,
Hmm.
into the subtraction of the final distance and current distance in that particular axis. So let me go to the whiteboard.
Okay. Are you trying to share something?
Yeah, can you see my whiteboard?
Yes, I can, but I don't think you're drawing anything.
Yeah, yeah. I was just writing down the formula. So suppose uh, at a particular point, suppose at 2 seconds. So this is the distance at x-axis that our object has covered, and this is the distance that our object has covered at y-axis.
Hmm.
So if we have this position, then we'll be able to plot our dots or whatever game object it is
Hmm.
uh, to render our line,
Hmm.
to draw our line. So we can use this equation. We know the initial velocity that we are inflicting on this body when we release it.
Hmm.
We know the acceleration, which is nothing but the overall gravity
Hmm.
being inflicted on this object, and we know the position from which we are releasing it, so the initial position. So through this formula we can just calculate the final velocity along the x-axis, and similarly we can use the same formula for calculating the final position at with respect to y-axis. So we can use this to calculate the position of the uh, line to be drawn, the path to be drawn at a particular time.
Hmm.
So this way we have to basically use this for uh, uh,
Where is the time side of
yeah,
things? Okay, that's fine. You're on the right track. You just chose the wrong formula. So if you Google like projectile motion based on time, or even on Wikipedia, etc., you should be able to like find a formula that actually gives you, hey, if I want to find X position of this particular object, this is what the force is, what the initial and final velocities are. Can
hmm.
give me the X position or the Y position? You can actually calculate those, and in every basically the entire duration you determine, and based on that you divide it into 10 different points and plot it on the screen. Cool.
Cool.
Okay. I think that's about it. Do you have any other questions before we wrap up?
No, that was fun.
Fun. It
Yeah.
was fun for me too. Cool. Someone from the HR team will probably get back once we are done with the other interviews or other candidates that we have to interview, and
Okay.
pick it up from there. Okay.
Okay. Sure.
Okay.
Okay. Thank you.
Yep.